Good evening. Well, he already told you that I'm not even able to tell you a decent joke, so bear with me. I will try to talk into natural refrigerants, and I'm the one with the most text, and I'm not even able probably to talk freely, but as I said, bear with me. Maybe you're going to be a fan of natural refrigerants later. I think we can all agree that the demand for refrigeration and air conditioning is increasing, and not only because of the global warming, but also an increasing population is demanding more chilled and frozen food, and thanks to better living standards, more and more people like to enjoy the comfort of air conditioning. Well, the ideal refrigerant, I'm sure you have heard this before, is a combination of excellent thermodynamic properties, good chemical and physical characteristics. It should be economically available, it should have no or low environmental impact, and it should be safe to use. In the past decades, the focus has mainly been on the safe use aspect of refrigerants. The definition of safe in codes and standards was and still is related to the immediate vicinity and people dealing with the substance, not so much on how people further away are affected, whether they are, for example, life-threatening conditions due to global warming. We know that this must change in order to keep global warming below 2 Kelvin. In any case, we cannot continue with business as usual if we want to meet the climate targets. In 2018, which is just a few months down the road, Europe has committed itself to reduce greenhouse gases by 40%. With the current situation, this is not likely to happen. Therefore, everybody needs to get involved and start looking into solutions with natural refrigerant. Big global companies are considering solutions, for example, with CO2 or propane, but so far there is no real demand, meaning everybody is on hold waiting what will happen next. One aspect why everybody is waiting is the fact that there is, in a lot of cases, a higher safety risk to be considered. And particularly big US companies are afraid of legal persecution and don't want to be the first. So far, harming the environment and its consequences does not have the same status, respective cost associated, than a higher safety risk for the people working with a refrigeration or air conditioning system. The results on global warming and contamination of water and soil will also harm people and create unforeseen costs, although not as immediate, not in the near vicinity, but further away, maybe even on another continent. But most likely, many more people will be killed from the destructive effects on the environment than with accidents with flammable refrigerants in the past decades and in the coming future. It's important now to change the thinking and consider more the global safety as a whole. This will mean a revolution when it comes to creating safety standards. The focus can no longer just be on what could happen to the person maintaining or working with a refrigerant system. This is important, don't get me wrong. We should not compromise when it comes to making the system as safe as possible. But we should also consider and evaluate the safety of everybody living on this planet. The evaluation on what is dangerous and to what extent is a challenge that so far has not been seriously taken up. We should not just consider global warming, but also the impact on the environment as a whole, including water and soil. New generation of synthetic refrigerants, such as HFOs, have a very low GWP value due to the fact that they decompose within a short period of time. But one byproduct of said decomposition is trifluoroacid acid, which is also formed as a byproduct of other synthetic refrigerants, but with HFOs in a 10 times higher concentration than, for example, for the popular R1234A. Considering the growing demand will result in unforeseeable consequences for water and soil. Is it safe then to use? We will have to shift from an approach fits all to a more clever engineering. It's pure physics and cannot be changed that a refrigerant meeting ultra-low GWP values is going to be flammable, with the exception of CO2, of course. This cannot be denied. Therefore, no matter what refrigerant we want to use, whether it's natural or a new synthetic one, we must conduct a risk assessment to ensure the safe handling of the refrigeration or air conditioning. Dealing with proper engineering and risk assessment before the project is started will give the additional chance to realize savings for operational costs, particularly when considering overall system design and interaction of the different building sectors, such as heating, ventilation, and refrigeration. The one refrigerant fits all is no longer available. Maybe it never existed. As with everything, also natural refrigerants have advantages and disadvantages. Some are flammable, some are also toxic, and others are less efficient for various applications. Ammonia is one of the oldest refrigerants in use, and look back at more than 125 years of experience. It has always continued to be first choice for industrial refrigeration, and you will most likely find an ammonia refrigeration system when it comes to larger distribution centers, food processing, chemical or pharmaceutical industry. We will find no other refrigerant that has a broader fan base than ammonia. People who have used it once will always return to it, and that for good reasons. Ammonia is the most efficient refrigerant of all due to its superior thermodynamic properties. It has low cost due to its vast use in industry and agriculture. Only less than 2% of the produced ammonia ends in refrigeration. Although it's toxic and in certain concentrations flammable, it's very hard to ignite, and as such has such an irritating, pungent odor that it's self-alarming, which means nobody will voluntarily stay near concentrations that are health-threatening. Many public buildings have chosen ammonia for their good efficiency and safety record. Unfortunately, not many are known to be run with ammonia, given the fairly bad image it's still having, undeservingly. Large arenas and sport facilities, such as O2 Arena, but also exhibition centers, banks, and other public buildings, are relying on ammonia for their air conditioning system. Ammonia also complies with the high safety standards set forward at railway stations and airports, such as the one in Stuttgart, London Heathrow, Terminal Zurich, and many more. And not to forget that ammonia is a refrigerant of choice for the International Space Station and biosphere too. And ammonia is no longer the refrigerant of choice for larger capacity systems, but research and development in the past years have led to excellent systems down to 50 kW and even smaller nowadays. Many other small ammonia systems are becoming available, but it still lacks in numbers. It's possible to minimize the risk of ammonia to an acceptable minimum, as it's proven by its excellent safety record, also compared to synthetic refrigerants. It's less likely to have an ammonia accident than being hit by lightning. However, it's essential risk assessment and safety standards are in place and adhered to in order to maintain this good safety record. As always, respect and good education is the key to successful behavior. A lot of research has been done with CO2 applications in the past 20 years, and it seems to be the refrigerant of choice for many end users, particularly those insisting in a so-called A1 refrigerant, which means non-toxic, non-flammable. Particularly at higher ambient temperatures, it is, however, less efficient than comparable synthetic refrigerants or ammonia or propane. It's particularly suitable for low-temperature applications and heat pump applications because it outperforms other refrigerants in regards to energy efficiency. Fish trawlers were, under the first users, appreciating the rapid cooling down to -50 Celsius for improved product quality of fish. At first with ammonia CO2 cascade systems, and recently with transcritical CO2 systems for small and medium-sized trawlers. CO2 is one of the preferred solutions for supermarket refrigeration systems, particularly in Northern Europe. With new ejector and expander technologies, it seems to be feasible also for warmer climates. For some application, there is still a battle ongoing in regards to what is the best refrigerant. Not only the automotive industry, but also transport cooling is looking into applications using carbon dioxide, but no final decision has been made. If the decision is in favor of CO2, we need to accept the higher energy consumption in warmer climates. Hydrocarbons are efficient, even at high ambient temperatures, but they are available everywhere and low in cost. But the system needs to be well designed and tight, as the refrigerant is highly flammable. With any flammable synthetic refrigerant, carbons can be used safely when applied correctly, as it's demonstrated in refrigeration and air conditioning systems used today. When butane was proposed for household refrigerators nearly 20 years ago, the risk was considered way too high from US safety departments. Scenarios were presented where the refrigerator would explode when opened. Today, nearly all household refrigerators outside the US are operated with butane without major incidents. Numerous bottle coolers and commercial freezers are operated with either butane or propane, particularly with charges below 150 grams. Many of those in the US today. Standard domestic split air conditioning systems, as well as potable air conditioners and dehumidifiers, are built in China today. Many car refrigerators worldwide use propane as R22 replacement, some not even labeled properly, which is unacceptable. Some supermarket chains are operated with propane for cooling and air conditioning needs, and even public buildings are realized with propane chillers for air conditioning and server room cooling. Propane used in refrigeration or air conditioning systems with some 100 grams or less are regarded a high risk, but propane for bottles for cooking or outdoor heating with several kilos, or flammable gases formed in the gas tank of each car are regarded an acceptable risk. You wonder why. When restricted to confined areas without sources of ignition, which means prohibition of open fires of any kind and limited charge, ignition should be impossible. In tests, it was shown that if ignition takes place, it's a short deflagration without major damages to insulation or other materials of the system. Risk assessment, not only for transport cooling, have shown that hydrocarbons are safe to use, even when other risk assessment for the same applications have come to other conclusions. We will see in the future which way will be taken. Besides the politics that are ongoing, natural refrigerants have proven to be energy efficient and safe. It's advisable to leapfrog further synthetic refrigerant options and look into the natural choices to have a future-proof solution. Feel free to ask me later if you have further questions or visit our website, euromon.com. Thank you very much.